guys, today's lesson is on the synthetic division method of dividing polynomials. The idea for the synthetic division method is to multiply and add, where the long division method is multiplying and subtracting. The first thing we have to do is actually set up this procedure in which we're going to first deal with our divisor, x plus 3, the binomial, and what we're going to do is only use the opposite value of the second term of just the integer. And by the opposite value, as you can see how it's positive 3, we're going to use negative 3 to set up the synthetic division process. Similar to the long division method, we do have a division bracket. However, it is this small bracket just encompassing that value we got from our divisor, the opposite sign of the second term. Synthetic division method doesn't deal with all of the terms. It actually just deals with the coefficients for all of the terms. So the next thing we're going to do is list the coefficients in order of the polynomial that we're dividing. The first coefficient being 2, the second coefficient being 3, the third coefficient being negative 4, and the last coefficient of 15. You're going to leave a little bit of space below and draw a line in which we can now start this synthetic method procedure. Step 1 is to drop down the first coefficient. We're always going to be multiplying times negative 3. We're going to multiply diagonally and add straight down. So what we have is 2 times negative 3, which is negative 6. We're going to place or record that value here and under the next column and add straight down. 3 and negative 6 is negative 3. We're going to repeat that process. We're going to multiply diagonally, negative 3 times negative 3, which is positive 9. I'm recording on the next column, and I'm adding straight down vertically. Negative 4 and 9 gives us 5. Repeat the process, multiply diagonally. Negative 3 times 5 is negative 15, and we're going to add straight down to get 0. Once each of the columns are filled and the process ends, the last value or integer we get underneath the line is going to be our remainder. So in this case, we know that the polynomial is evenly divisible by the binomial x plus 3, since we get no remainder. How are we now going to record our answer? These coefficients that we have left on the bottom are the coefficients to our answer, in which we'll start 1 degree less than the polynomial we're dividing. The polynomial that we're dividing, 2x cubed plus 3x squared minus 4x plus 15, has a degree of 3. Therefore, our answer is going to start with a degree of 2, or x squared. The coefficient for that first term is the first coefficient we have here, which would be 2x squared, following minus 3x plus 5. Notice that the degrees are decreasing by 1 as we continue each term, and since we have a remainder of 0, this would be our final answer. Let's go ahead and check out problem number 2. Again, to set up the synthetic division method, we're using the opposite value of the second term of our divisor. Since it's negative 2, we're going to use positive 2, and then list all the coefficients of the polynomial we're dividing. First one being 3, then negative 8, then 11, then negative 14. Draw a line, and we can now begin the synthetic method of dividing. Step 1 is pulling down or dropping down the first coefficient. We're going to multiply and add. Multiply diagonally, 2 times 3 is going to give us 6. And add vertically straight down, negative 8 and 6 is negative 2. Multiply diagonally, 2 times negative 2 is negative 4. 11 and negative 4 will give us positive 7. 7 times 2 is 14. Add vertically straight down, we get another remainder of 0, meaning that the polynomial will divide, or dividing is evenly divisible by the binomial x minus 2. Similar to problem number 1, the degree of the polynomial we're dividing is 3. So the degree of the answer is going to be 1 less. It's going to start with a degree of 2, in which the values below are the coefficients of the terms in our answer. We'll start with 3x squared, and the degrees decrease by 1 each term. Minus 2x plus 7. Problems number 1 and 2, similar to long division, the polynomials we're dividing had each degree in succession. For example, problem number 1, as you could see, we had a degree of 3, then 2, then 1, then 0. There were no missing degrees or terms. In problem number 3 and 4, we might be having a missing degree or term in which we're going to have to add in a placeholder just as we would in long division. Notice in problem number 3, we start off with a degree of 4, then 2, then 1, then 0. Which degree in this case is missing? That would be the degree of 3, or the x cubed term. So when we go ahead and set up the synthetic division method, we're going to use negative 2 and list the coefficients, but since the x cubed term is missing, we'll use a coefficient of 0 as its placeholder. In problem number 1 and 2, we did not have to put a placeholder in because every degree or every term was there. Since the x cubed term is missing in problem 3, we put our placeholder of 0 in. We can now continue the process of synthetic division, dropping down our first coefficient, and we're going to multiply diagonally and add. Negative 2 times 4 is going to give us negative 8. Add straight down, we get negative 8. Multiply diagonally, negative 2 times negative 8 is positive 16. Record it in the next column and add straight down to get 18. Multiply diagonally, negative 2 times 18 is negative 36. Add straight down. Negative 36 and negative 4 would be negative 40. Multiply diagonally, negative 2 times negative 40 is positive 80. Add straight down to get now a remainder of 92. Remember that the last digit that we get under the line is our remainder, in which problem 1 and 2 we didn't get a remainder at all. The values below the line are the coefficients to our answer, in which we'll start 1 degree less than the polynomial we're dividing. The polynomial that we just divided had a degree of 4. So we'll start with a degree of 3, or the x cubed term. The coefficient for that term would be 4x cubed, and the remaining values will be the coefficients for the next terms, 1 degree less than the previous. Minus 8x squared plus 18x minus 40. And similar to when we were doing long division, we're going to add that remainder at the end as a fraction. We have 92 left out of what we're dividing by, which is the binomial x plus 2. Problem number 4 is very similar, such that there is a missing term. What I'm going to ask you guys to do is try problem number 4 yourselves. Make sure that you add the placeholder in for the missing term and proceed with the synthetic division method. Once you get your answer, play the video back to check. Here's your answer for problem number 4. The degree or term that was missing was the x squared term, in which we need to put the placeholder of 0 in 4 before starting the synthetic method of division. Completing the method, we're going to get a remainder of 42, in which when you write your answer, we'll start off with a degree of 3, or the x cubed term, using the numbers at the bottom as the coefficients. At the end, we will express our remainder as adding 42 out of x minus 2. Please let me know if you guys have any questions on the lesson, and I'll talk to you soon.